Welcome to the interview stack. Sorting is one of the most common operations that we perform in real world programming, but here's the catch. There isn't just one sorting algorithm. There are many, each with its own strengths, weaknesses, and trade offs, right? So, in this series, we will be looking at different sorting algorithms and break down their core logics so that you get to understand the trade offs related to each sorting algorithm. But before we dive into any specific sorting algorithm, it is really important that we understand a few key terms that help us evaluate which sorting algorithm works best for a given scenario. The first term that we need to understand is in place versus not in place sorting algorithms. If a particular sorting algorithm uses only a small or a constant amount of extra memory, that is referred to as an in place sorting algorithm. On the other hand, if a particular sorting algorithm requires additional memory which is proportional to the input size, that would be referred to as a not in place sorting algorithm. So, for an array of size n, a not in place sorting algorithm might require an additional data structure or an additional array which will occupy memory that is proportional to the size of the input array. Now, why does this matter? There are several scenarios in real world programming where you will be working on systems that are memory constrained. You will not be having the freedom to go ahead and use as much memory as possible. So, you should be writing your algorithms in such a way that they occupy as less memory as possible. So, in such scenarios, an in place sorting algorithm would be preferred because it doesn't require any extra space that is proportional to the input size. So, even if the input is of the order of millions, it doesn't use extra space that is proportional to millions. Let us now look at stable versus unstable sorting. Now, this is also really important. Stable means that a particular sorting algorithm preserves the relative order of equal elements. Unstable sorting algorithm does not guarantee preserving the original order of elements, right? So, if two equal elements appeared in a certain order, after sorting, they might appear in a different order. And unstable sorting algorithm does not guarantee if they preserve the order of the equal elements. Let us take a look at this example. Imagine your input looks something like this. Every object has a name and a score associated with it. Now, a stable sorting algorithm will guarantee the relative order of elements having the same score. For example, in this particular data, you can see that Alice and Charlie have the same score of 92. A stable sorting algorithm will make sure that Alice and Charlie appear in the same order as they did in the original array. On the other hand, an unstable sorting algorithm might not guarantee the order. Sometimes Charlie might appear before Alice even though they have the same score, and Charlie appeared after Alice in the original list. Now, why does stability in a sorting algorithm matter? In certain environments, it is required that you preserve the original order of elements, and in such a scenario, you should be using an algorithm that is stable. Certain algorithms like bubble sort are stable, and you should be focusing on such algorithms if you have a constraint that requires you to keep the relative order of equal elements. Let's now look at comparison based versus non comparison based sorting algorithms. Comparison based sorting algorithms work in a very simple manner. They compare the elements involved and make the decision based on that. Non comparison based sorting algorithms are different from your regular sorting algorithms. These algorithms use different techniques such as counting, hashing, and several other special techniques to determine the relative order of elements. Non comparison based sorting algorithms are not frequently asked in interviews, but it is good to take a look at these algorithms. And how does this matter? For example, if you know that the data that you will be sorting will be within a particular range of elements, you can use different sorting algorithms which can be better than n log n time complexity, right? So, comparison based sorting algorithms have a lower bound of n log n. They cannot do better than that. But if you know that your data is of a particular order and it satisfies certain special characteristics, then you can go for non comparison based sorting algorithms and they can provide a time complexity that is better than n log n. But remember that these non comparison based sorting algorithms work in only special cases, and that might not always be the case. Now, let's take a look at adaptive sorting. If an algorithm takes advantage of the fact that the input is already sorted or partially sorted, such an algorithm is called adaptive sorting. Now, there are certain algorithms which reduce the number of operations if the input is partially sorted, On the other hand, there are algorithms which always do a particular number of comparisons, particular number of operations, irrespective of the array being partially sorted. So if an algorithm adapts to a scenario where the input array is partially sorted, such an algorithm is called adaptive sorting algorithm. Insertion sort is a good example. It performs very well of the order of big O of n when the input is nearly sorted. On the other hand, sorting algorithms like selection sort always do a particular number of steps, so they don't adapt to the scenario if the input array is partially sorted. Such an algorithm is not an adaptive sorting algorithm. So we took a look at different keywords that will be useful while evaluating a sorting algorithm and seeing if a particular sorting algorithm is a fit for a particular scenario. Now, one quick interview tip regarding sorting is that sometimes you will be asked which sorting algorithm should be used. In such a scenario, you should always be aware of the data that you are dealing with. If the data is within a limited bounds, or are you working in a space constrained environment where you are required to use as less memory as possible, or if stability of the input data is really important, or if the input data is already nearly sorted. By this point, you are already aware which algorithm should be used in which scenario, and after getting the answers to these questions, you should be able to identify the correct algorithm for a particular scenario. So with that, you are fully equipped to go ahead and learn in depth about different sorting algorithms. Remember to download your notes from the description and turn on closed captions so that you have a better learning experience. Thank you.